Now come to the hysteresis. Hysteresis, this phenomena has been observed only in the ferromagnetic material. So what has been found in the ferromagnetic material? When the ferromagnetic material kept in a external magnetic field, and due to that external magnetic field, a magnetic field developed inside a material, that is called magnetizing field. So as we are increasing the magnetic intensity, the net magnetization in the material increases. After reaching the saturation state, when all the domain of the material get aligned in the direction of external magnetic field, so then the magnetization become your constant. So what has been found, if we are removing the external magnetic field gradually, so net magnetic field inside that is also decreases. But if we have removed the complete external magnetic field, but then also there is some magnetic field left in those material. So that phenomena is actually called your hysteresis. So how we can define? See, let this is your external any magnetic material. This is let any ferromagnetic material is there. A ferromagnetic material. A ferromagnetic material is here. Now, when we are applying a magnetic field H, H is a vector. Now see, if we are plotting a graph. So let this your B is the net magnetic field versus H graph. So what has been found? H is your intensity of or magnetic intensity. H is called here magnetic intensity. The magnetic intensity means that is the external magnetic field which we are applying here. Due to this H magnetic field inside that, B is the net magnetic field, and which is depends on the nature of material as well as their magnetization. So as H your increases, so what has been observed? B is also increases like this. So let at the starting means when we are not applying any magnetic field, H is here 0. As we are increasing, so net magnetic field your increases. So 0 to A, let this is the situation comes here. This is your saturated field now, saturated magnetization complete here there. Now, if I am decreasing the H value, if I am decreasing the value of H, it means then what we have found, there is no, or the graph will not follow the same path as it was following from O to A. So it will be some different path it is following, and even if we are decreasing the H value and it making at 0, 0 means finally no magnetizing field, then also there is some magnetic field left here, this. It means that is called, you can say, residual magnetic field left, even making H is equal to 0. So that residual magnetic field is called your retentivity. This is called your retentivity. So now, so whatever residual magnetic field left, to make that residual magnetic field 0, we have to apply H value in the reverse direction. We can say like this. Now H is your in this direction. To nullify the residual magnetic field, to nullify the residual magnetic field, to nullify the residual magnetic field. So this will act in this direction, so that will go like that. So this is the value of that H required, so that is called coercivity or coercive force. Coercive force, and this phenomenon is called coercivity. So some of the opposite field is required to make here. Then again if we are applying the field in the reverse direction, then again we will follow this type of graph. So this curve is called your hysteresis curve. So that indicate here this term is retentivity, and here your coercive force, and this phenomena is called coercivity. So this is the, so what is the main point here in the hysteresis curve? When we have found the area of that curve gives the area of the curve gives amount of heat dissipates per unit volume in the magnetization and demagnetization process. In the magnetization and demagnetization process. Magnetization and demagnetization process. So area of the curve gives amplitude, this gives the amount of heat dissipate per unit volume in the magnetization and demagnetization process. So if more retentivity, it means more residual magnetism is there. So from those type of material which are showing more retentivity or more coercive force, so those material has been used to make a permanent magnet. So we can write certain point. First point we can say the materials which are showing more retentivity, and coercivity are used to make permanent magnet. So examples for that is, examples are alnico. Alnico is an alloy of iron, aluminium, and nickel and cobalt, This is used to make a permanent magnet. And the area of the hysteresis area or the area of hysteresis curve, of these materials is more or large. Similarly, second point we can say, similarly, the materials which are showing less retentivity retentivity and less coercivity are used to make temporary magnet The examples of those examples are soft iron and the area of hysteresis curve, the area of hysteresis curve for these material is very less. So that curve we can say this is, let for example, this is your for permanent magnet or for permanent magnet, or if we want to make for soft iron. So for soft iron, if we are able to make the curve is very less or steep curve like this. This is the for soft iron. So this is the general idea about your hysteresis. The hysteresis curve that give us only when we are applying external magnetic field, so the material get magnetized. Even if we are removing the all external magnetic field, so but the magnetism still remain within the material, and that magnetism or that magnetic field is called residual magnetic field, and this phenomena is called retentivity, and that is give you the, so to make nullify we have to apply external magnetic field in the opposite direction. That external field is called coercive force, and this phenomena is called coercivity. Now see few example based on magnetic properties of the material.